Hello class, we're about to start Unit 2 Fractions, Multiplication and Division. Section 8, Reducing a fraction to simplest form, is also called lowest terms. Two fractions can look different but have the same value. These are called equivalent fractions. Write the fraction for each picture. Okay, now, if you notice here, we have 6 boxes here, which is the total, so that'll be the denominator. Then we have 3 shaded, which would be the numerator. So this is 3, 6. Here we have 2 total boxes here. So the total is 2. And we have 1 that's shaded. These two are equivalent because both of them are half of this figure, even though they look different. And we've dealt with that all of our life because we know 4 quarters is $1. So now, we come here. It says mathematically we know that we create an equivalent fraction whenever we multiply or divide the numerator and denominator by the same number. This is because we are really multiplying or dividing by a form of the number 1, which doesn't change the value of the original fraction. Now if we look here, we take 1/2 and multiply by 3 over 3. That'll give us 3 over 6. Now remember, any number except 0 divided by itself is 1, so it's not changing the value. Now we come here with division. 3 divided by 3 is 1. 6 divided by 3 is 2. Now, 3 over 3 is still considered 1, and we know anything divided by 1 is the same value. So it did not change the value, it just looks different. Now, when a fraction is written using the smallest possible numerator and denominator, we say the fraction is in simplest form or lowest terms. To reduce a fraction to its simplest form, find a number that divides evenly into both the numerator and denominator and divide. Hint, the process will go faster if you use the biggest number you can think of that works. Next, repeat this process until you can't find any more numbers that divide into both numerator and denominator evenly. Examples, reduce each fraction to simplest form. Now we have 6 and 15. Now we know that both of these are not even, so we cannot divide both by 2. But 6 and 15 both has 3 in common. So we could divide the numerator and denominator by 3. 6 divided by 3 is 2. 15 divided by 3 is 5. And 2 and 5 only has 1 in common, so we're done with that problem. Now we come here to 40 over 70. Now because these end in 0, we know we can divide both by 10. So 40 divided by 10 is 4. And 70 divided by 10 is 7. And that is the final answer. We can't simplify that anymore. Now we look here at 54 and 72. Now if you don't know what goes into 54 and 72, both of them are even, so we could start off with the number 2. We could divide both by 2. 54 divided by 2 is 27. 72 divided by 2 is 36. Now with 27 and 36, they're no longer both even, but 27 and 36 both has 3 in common. 27 divided by 3 is 9, 36 divided by 3 is 12. Now 9 and 12 also has 3 in common. 9 divided by 3 is 3, and 12 divided by 3 is 4. Now 3 and 4 only has positive 1 in common, so that is finished. Now we could have divided all of this by both of them by 18, and that would have been the largest number. But remember, you could use smaller numbers as long as you get it to simplest form. Now 28 and 84, I still would just use 2, since both of them are even. So that would be 14 over 42. I would still use 2 again. So that would give us 7 over 21. Now 7 and 21 both have 7 in common. So it'll give us 1/3. And there's nothing more we could do with that. Now, we come here to page 9. It says section B, multiplying fractions. You can multiply fractions straight across, numerator times numerator, denominator times denominator, and then reduce the answer. So we can multiply straight across. 8 times 3 is 24, and 9 times 4 is 36. Now we can simplify this. Both of them are even, so we can divide both by 2. So that'd be 12 over 18. They're still even, so we can divide both by 2. And this will give you 6 over 9. Now you can divide both of these by 3. And this will be 2/3. And that is the final answer. Now it says, however, many people find it easier to reduce before multiplying. Reduce either by numerator with either denominator. Now, one thing I want to say about the previous problem is this here. Feel free to use larger numbers if you want to in simplifying. You don't have to use the lower numbers. I just choose to use that just to show you that there's another method. Now here, what they're talking about with as far as reducing before multiplying, you have to make sure that their fractions multiply to each other. If they have a different operation, then you cannot use the method that I'm about to show. So we look here at this first numerator 8. We look directly beneath it. 8 and 9 has nothing in common. Then we will go diagonal. 8 and 4, they both have 4 in common. So you can divide both of these by 4. 4 goes into 8 twice, and 4 goes into 4 one time. So you simplified out 4 with both of them. Now we look here. 2 has nothing in common with 9, and 2 has nothing in common with 1. So now we look here at this 3. 3 has nothing in common with 1 except for 1, but 3 and 9 both has 3 in common. So we could divide this by 3 and give us 1, divide 9 by 3, which would give us 3. So our new fractions would be 2/3 times 1 over 1, which is just 2/3, which is what we got from the previous problem. Now we go down here to examples. It says multiply the fractions or mixed numbers. Note that mixed numbers must be changed to improper fractions before multiplying. Give all answers in lowest terms and in mixed numeral form where appropriate. Now, when they ask you to put this in lower terms and in mixed number form when appropriate, there's only a couple situations where you actually need to put it as a mixed number. One, if the instructor tells you to write it as a mixed number. And 2, if the directions tell you to write it as a mixed number. Or 3, if you started out with a mixed number and you had a possibility of giving a mixed number for your answer, you should give a mixed number as your answer. So now look here. First of all, neither one of these are mixed numbers. And the directions do not tell you to write it as a mixed number. It just says where appropriate. And the instructor, well, I don't know if your instructor is telling you to write it as a mixed number. If they are, do it. If not, then you're free to write it as a fraction. Now let's go here. Let's do the simplifying. The cross simplifying, since it's all multiplication. 3 and 14 has nothing in common, but 3 and 15 does. They both have 3 in common. 3 goes into 3 once. 3 goes into 15 5 times. Now we try this 4. 4 and 5 has nothing in common, but 4 and 14 does. They both have 2 in common. 2 goes into 4 twice. 2 goes into 14 7 times. So our new fractions would be 1/7 times 2/5, which will give us 2 over 35 when we multiply straight across, and there's nothing more can be done with this. Okay, now we look here. We have a negative times a negative. We know a negative times a negative is positive. So now we can do our cross simplifying again. 9 and 10 has nothing in common, and 9 and 12 both has 3 in common. 3 goes into 9 3 times. 3 goes into 12 4 times. Now 5 and 4 has nothing in common, but 5 and 10 does. Both of them can be simplified out by 5. 5 goes into 5 once, 5 goes into 10 twice. So our new fractions would be 3/2 times 1/4. Now remember, we know a negative times a negative is a positive, so we don't need to write the negative sign here, because we know our final answer is going to be positive. So 3 times 1 is 3, and 2 times 4 is 8. So that is the final answer. Now we come down here. We have the whole number 4 times 5, 6. Now whenever we have a whole number times a fraction, I always encourage you to put a 1 under that whole number so it'll now be a fraction times a fraction. we could do simplifying. 4 and 1 has nothing in common, but 4 and 6 has 2 in common. So 2 goes into 4 twice, 2 goes into 6 3 times. And then 5 has nothing in common but 1 with 5 and 3, and then 5 and 1. So now our new fractions would be 2 over 1 times 5 over 3, which will give us 10 over 3. Now, since our problem started off with a whole number, I should have said start off with a whole number or a mixed number. Since we could change this to a mixed number, so let's do that. We would take 3 into 10. 3 goes into 10 3 times. 3 times 3 is 9, and you have a remainder of 1. Now, we want to change this improper fraction. Improper just means that the numerator is either the same or larger than the denominator. Or put it in these terms, the top is larger or the same as the denominator, which we have here. So now, we want to write this as a mixed number. So this number before you get to the remainder, that will be your whole number. The number that you divided everything by would be your denominator. And the numerator is your remainder. So it'll be 3 1/3. Again, let me go over that. The number that you have before you do your remainder, that is your whole number. Okay, now, your remainder is the numerator of your fraction. Your denominator is the number you divided by. Okay, now we come here to this problem. Now we have a mixed number times a mixed number. First, let's take care of this. A negative times a positive, we know our final answer is going to be negative. So we don't even have to revisit the negative sign until we write our final answer. So now with these mixed numbers, we need to change it to improper fractions. First of all, the denominator will stay 3, and this denominator will stay 4. So when you're changing mixed numbers to improper fractions, your denominators do not change. Now we go for the numerator. We would take 3 times 3, the whole number times the denominator, plus the numerator. 3 times 3 is 9, plus 1 is 10. And then we will add 1 times 4 is 4, plus 3 is 7. Okay, so now we'll see if we can simplify before we multiply. We can't. 10 doesn't have anything in common with 3 and 4, and 7 has nothing in common with 3 and 4 except 1. So we'll multiply straight across. 10 times 7 is 70, and 3 times 4 is 12. Oh, so actually, I made a little error here. Let's go back. We can do some simplifying with 10 and 4. Both of them has 2 in common. So we could say 2 goes into 10 5 times, 2 goes into 4 twice. So then we can multiply. And we have 5 times 7 is 35, and 3 times 2 is 6. So now, you notice here the numerator is larger than the denominator. So we'll take 6 into 35, because remember we started with mixed numbers. 6 goes into 35, let's see, 5 times. So we have a remainder of 5. So our final answer would be a negative 5. The denominator will remain 6, which we had here, and the numerator is the remainder. So now we move on. We go here to the next page, to section C, applications of fraction multiplication. It says multiple items. Sue bought 3 packages of hamburger. Each package contained 2 3/4 pounds of meat. How many pounds of meat did Sue buy? So first of all, we know that one package is 2 3/4. And they said she bought 3 packages of that. So we can multiply that by 3. So we'll change this mixed number to an improper fraction. The denominator remains 4. 2 times 4 is 8, plus 3 is 11, times 3, and we'll put that over 1. Now, there's nothing we could simplify here, because 11 doesn't have anything in common with 4 and 1, and 3 doesn't have anything in common with 1 and 4. So that would be 33 over 4. Now, since we started with a mixed number, we could rewrite this as a mixed number. So we'll go 4 into 33. So we say 4 goes into 33 8 times. 8 times 4 is 32, and we have a remainder of 1.